I'm Kate Davis, Deputy Editor of Fast Company, and you're about to listen to a custom episode brought to you by Fast Co-Works in partnership with AWS. We'll be back with more The New Way We Work next week. Enjoy!
I'm Scott Alexander, and this is At the Edge of Innovation, a custom podcast from Fast Co-Works and AWS. Today, we're talking with AWS's Jan Hofmeyr, who's going to give us the latest on what's taking place in the hybrid cloud and edge computing space today, and what we can expect in the future as edge computing becomes ubiquitous. We'll also explore how these innovations can ultimately help you transform your business. Joining me is Jan Hofmeyr. He's a vice president at AWS overseeing their hybrid edge computing business. Thanks for joining me, Jan.
Thank you very much, Scott. Great to be here today.
Can you start by telling us a little bit about what you do at AWS?
At AWS, I run what's referred to as the EC2Edge organization that is really focused on how do you bring the AWS compute that runs in our regions and our big data centers, and how do you bring it closer to our customers? So whenever we take the AWS cloud and we want to bring it closer to the customer, that's what my organization and team is focusing on.
And are there specific strategies that you employ to do that?
Absolutely. So for AWS, the promise we make to our customers is that regardless where you run your application, whether you run it in what we refer to as our regions are the large data centers where we have availability zones, redundancy, and that's where a lot of the workloads are running today, or the applications. How can you allow those same customers to take those applications and run them closer to their own on-premise? So my team, one of the big objectives and goal for us is how can we think of it extending what we run in our regions and then allow our customers to run it closer to the edge, closer to their own on-premise locations.
Got it. So you hear a lot about the edge nowadays, but it sounds like what this is doing is really using the edge as an extension of the cloud rather than its own thing.
Absolutely. It's we think of it as a continuum. And when we talk to our customers and we listen to their use cases and what they are focusing on, and you work back from that, they really don't want bespoke different solutions as they run in different locations. And we refer to it as the continuum. So ideally what you want to do is be able to build your application in AWS and take that same application and run it anywhere. And I'll give you a good example as a customer and as a developer. What it really means is you should be able to build your application, go to the AWS console where you manage your applications and where they run, and you should be able to say, run my application either in a region or in the edge. And they should be able to select any of those locations, deploy the application without any changes in terms of how they think about deployment, how they think about the distribution, and to be able to run that application wherever we have a presence. So our team's goal is to make the edge feel like you're running in AWS in our region.
Right. It sort of puts the cloud everywhere.
Exactly. The edge for us is not a thing. It's not a place. It is everywhere where we allow customers to run their applications. That's why we think of it more as a continuum than a physical location.
Right, and that tracks with the idea that you're going to create these programs once. A developer is going to create their applications one time, deploy it in the cloud, and then it can really travel to any spot it wants to.
Exactly.
So when I think of hybrid cloud and edge solutions, that includes everything from local zones, wavelength zones, outposts, Snow Family, IoT, that kind of thing?
I think that's a good list of what we have in a portfolio today of specific edge-focused areas. Just to give some context on the ones you mentioned, I'll start from the region. After you go from the region, the next step of getting closer to the customer is our local zones. And so they further distributed across the footprint. And then we have a special version of the local zone, which is called the wavelength zone, that runs inside of a carrier or a wireless carrier network. And that allows for, and we can talk about it a bit later, but that allows for very specific use cases to be solved by that. And then you go even further and you run in customer data centers. And that's where Outpost comes into play, where we allow you to run the Outpost within a data center. And then we go further than that. And, we announced the availability of the Outpost server. So today we have the Outpost rack that is truly think of that as a data center product. We now also have Outpost server that even can go deeper into smaller locations where you just want a single or a couple of servers. And then the Snow product takes it all the way into remote, rugged environments where you sometimes do not even have connectivity, but you would like to benefit from the same APIs, running the applications, and when it does connect, you get the full benefit of the cloud.
Yeah, I think I heard about an example of one of the Snow family of products going to space.
Yes, that was an exciting, very
That's
exciting.
amazing.
We were wondering what is the boundaries of the edge, and when that opportunity came up, you can imagine the boundaries suddenly expanded dramatically with going into space even.
Yeah, who knew you could put clouds in space? That's incredible.
Exactly.
Yeah, so that's interesting to put it in that context of sort of like moving closer and closer to the user. I actually set it in reverse. I started with Snowball, but it really would go local zones is the closest to the cloud, and then down into wavelength, then down into outposts, then down into Snow, where you can be completely disconnected and just attached to the user.
Exactly. And in each of them, have a very specific customer use case in mind that we address as you go down each of those steps. I can give you a few examples. As you get closer, obviously, you benefit from latency, but really with local zones, it's a great solution when you have data residency that might be state-based and you want to run it within a state. Also, it gives you latency improvements as you get closer and further out from the regions. With wavelength zones, now you are running inside of a 5G network. So for applications that really wants to be optimized for the best performance from a latency perspective, there is no better place to run than to be in the network. So from the phone connecting to the tower, going to the wavelength zone, that is in extreme close proximity from each other, and you get fantastic performance and latency there. And then, the outpost, we can talk about that, but this gives you all of the benefits, obviously, for running on-prem.
So would you think of the wavelength as being, it's a wireless solution, and then when you're connecting to a local zone, you're more going in a hardwired situation?
That is correct.
Right.
The wavelength zone really benefits from the 5G wireless connectivity. So think automotive, self-driving cars, where 5G technology is used to solve very specific real-world scenarios where latency is very important.
Mm-hmm. What are the kind of common use cases for these edge solutions?
Let's start with there's three main areas. The first one is around the latency. So we are definitely seeing latency driven. We spoke about that AR, VR, autonomous vehicles benefiting from the local zone. So that is a clear use case. The second one is as migrations how are happening, enterprise migrations and workload migrations are happening to the cloud. What we find that's very common is that there is a data gravity and an application gravity running in local data centers, on-prem solutions. And it's not always that easy to just take an application and move it directly into the cloud. So for those applications, putting Outpost into those data centers as the AWS cloud allows you to do that migration to the cloud on-prem. And then over time, you could start migrating them into the regions or into the local zones. But it really allows for that the migrations. We see so many customers that have these very, very large on-prem footprint. And this is a fantastic solution to allow and support that migration strategy to the cloud.
Is that because they're migrating processes that are running live as they're trying to migrate them? Is that why latency becomes a factor?
Yeah, there's a couple of things I will call out. So the one is, and I don't want to use the word legacy applications because they are doing fantastic work today and there's nothing legacy about them. These workloads that are running on-prem many times operate within a security environment that is not easily extendable. They are running in an environment where the latency between the data or the databases and the data and the other applications are absolutely critical. It's a much easier step towards becoming cloud native. It also allows them to migrate to cloud, start adopting all of the new cloud, or take the advantage of all of the cloud tools and processes and technologies. So you can benefit from that without having to really, as a first step, worry about the interactions between data and other applications. And you can make that as a step two once you have all of the tools available that is available in the cloud.
That's interesting. So it's often a simplest first step to migrating into the cloud.
Exactly. Mm-hmm. There's a belief right now that the applications that could easily move, many of them have already moved. Right? If it was easy to move them, they are running in the cloud. And so our focus really now on the applications that are remaining in these data centers and how do we make that much easier to transform these applications and move them to the cloud.
That was going to be my next question was, there has to be built up expertise at this point with this cloud being around for this long, that people are getting good at these migrations. And what I'm hearing you say is, yes, they are, to the point where everything that was easy to do has been done. So the next stage is, are you saying it's going into a new level of challenge?
It is just helping the customers, right, to make that migration easier. Many times what you see in companies, and I've experienced this myself, there's the haves and the have-nots. There's the teams that are running in the cloud. They have access to all of the technologies and tools that's made available with the cloud. And if you sit in those meetings, you will find that people talk about the next feature. They talk about what was just delivered, how it's performing. Data is just available to them. It's a very focus on innovation, focus on the next thing type of discussion. Then you transport yourself into the room where folks are talking about a application running in an on-prem data center, and the discussion is different. They talk about, where's my capacity? Where's my server? What happened last night? So you don't have visibility. It's a very different discussion. And we want to transform that group and give cloud to that group so they can run cloud native even in their own data centers.
It really sounds like these people are stressed out.
I think they are stressed out, and it's different degrees of stressed out.
And it sounds like, when you go to a cloud solution, it's sort of like operational complexity just reduces. And so you can focus on outcomes and what's next. That's a fascinating thing you've observed.
Yeah, Scott, if you think about it, right, what's one of the key values we bring with Outpost as an example to data center is that we bring AWS onto your data center, which means from your perspective, it's no different than you running in a region. And we take care of a fully managed infrastructure. We monitor it, we manage it. If something goes wrong, we respond. If you need capacity, we add the capacity. So it almost feels you have that elasticity that you can easily just expand. You're bringing the cloud model on-prem.
Right. It happens to be on-prem, but it's really cloud managed. It's managed in the same way that set it and forget it happens in the cloud.
Exactly.
I was fascinated to see Outposts moving down in size. I think originally they were these big 42U racks, and then they've gone down to a 1 and 2, I think, are available now.
That is correct. Yep. And the 2U server.
Are you seeing any kind of new use cases given how small that is, how able it is to go into smaller spaces?
Absolutely. It really are enabling a whole new segment of customers now having access to the same cloud capability. If you think about a 42U rack, it's truly a data center product, right? So you need a full data center and it runs in a data center environment. There are so many use cases where customers just want a server and an IT rack in a hospital,
right,
that runs the MRI systems, right, or in a factory where they don't have data centers, but they really have a need for cloud compute storage network. And the Outpost server really fits that use case very well.
And this is going down, I'm guessing a 42U rack is more like the size of a refrigerator, whereas a 1 or 2U is the size of a pizza?
Yeah, a good size refrigerator.
Okay.
A little bit heavier. Refrigerator down to pizza box. I think it's a really good analogy.
It's interesting that the medical piece of that, because that feels like that could be another place where regulatory compliance comes into play, that you must keep medical records in a certain jurisdiction or in a certain secure environment. Or is there compliance issues when it comes to the medical world?
Absolutely. It's a great use case for the exact reasons you mentioned. First of all, to your point, data residency, you know exactly where your data is running, although you can get that same capabilities in running in the regions as well. But for some use cases, it's just the data is now local, it's accessible. If you think the MRI machine takes the data, it puts it on an Outpost server, and is then consumed immediately by the local hospital or facility. And then that data can be made available anywhere else using the rest of the cloud of the region. So it can take advantage of that, but it just gives you that local capability within the hospital on-prem.
I'm wondering if there's some dots that connect here. I keep hearing about this model where AI and ML models are trained in the cloud and then deployed at the edge. And then I keep hearing about how MRI and medical imaging machines are using more and more ML inferencing to get to good outcomes. Are those coming together in that medical use case?
They are coming together in that use case. But, you just said something there. Develop in the cloud and then deploy at the edge. I want to give you a quick example because, in the beginning, we started off with this continuum, right? Continuum of the APIs. It's the same API, it's the same tooling, visibility, and so on, all the way down to an Outpost server. want to give you a quick example. We had a customer that for regulatory requirements, they get a license to operate in a state. And when the license are announced, they have a very short period of time until the license becomes valid. So they get issued the license, and then in their business, it's all about first mover advantage. If you can be first out with your application, your service, given a license, that is everything for that customer base. Because of the continuum, because of the APIs being the same, what we allowed this customer to do is build their application in the region in an environment that looks exactly like an Outpost. And by the time that the Outpost came up, they can just port it. So in this particular case, the license was issued. 15 days later, they gave us access to the data center where we could install the Outpost rack. We installed it, and 3 days later, the license became valid, and they launched on that same day. They were the first to launch. And the reason was they could literally, when Outpost came up, they could go into the console and say, deploy to Outpost. They deployed, and instantly that application became available. So that speed of deployment was really, when you were talking about the ML, you train and then you deploy. It's almost that same model that we allowed that customer then to be the first in that particular market to launch their service.
That makes an immense amount of sense. You can develop the whole product before you're legally allowed to deploy into that state. And then when you get the green light, you're up and running, you said the next day?
So we gave them the environment. They launched the next day.
Oh, wow. Okay, 24 hours?
They deployed it that evening, and then the next morning they went live.
Wow. If you were going to cast your mind back to the bad old days before these options were available, if you were trying to stand up a data center, you're someone like, there's all these sports wagering sites that are kind of legalized in one state and not in another state, and they're getting licenses and needing to stand up data centers quickly. If they didn't have these advantages, how long do you think it would be taking them to sort of stand up these solutions?
We typically hear from customers that, building this yourself and then creating it, it's typically a 3 to 6 month period.
Versus 24 hours.
Versus what we did. So the whole process from us, from the time they got their license to they placed the order till they were live, that happened in 30 days.
Okay, so the overall process is faster, and then actually you can pre-build it all and then just deploy within 24 hours. That's incredible.
Exactly.
What are the biggest challenges AWS has faced as it's developed these tools?
I would categorize this as two main areas. One is when we bring AWS through Outpost on-prem, you bring it in an environment where the culture and the people are used to buying servers, managing software updates. That it's very operational intensive. And here we come in with Outpost, we put the rack down, and all we ask them to do is give us power and network connectivity. And then their end users, their customers, have access to it, and they start using it, meaning their developers. And the first thing they would ask us is, how do we make sure that it's working, right? How do we make sure that it has the latest update? It's a real mind shift for the folks receiving these racks, because they've been operating these things and been building it almost real time, right, and responsible for every aspect of it for so long. And suddenly this rack shows up and it just works. And so that's a very interesting transition for these teams.
It's not even quite education, but it's more mindset, changing the structure of how you're thinking about managing these types of applications.
Exactly. For me, what's amazing is when you then give them access to the visibility they now have in terms of that infrastructure, they have so much more visibility because we provide through CloudWatch and CloudTrail. I mean, they've got tremendous amount of visibility of this environment that they've never had before. And we also break down the silos now in these organizations, because the same visibility that team who runs the data center, the developer has the same visibility. So that communication now between those two groups that traditionally have been kind of stressful and speaking two languages, suddenly they speak the same language. They see the same thing. I think it really creates a much more simplistic operating model for these companies.
Do you see people sort of trying to protect that operational complexity at all and saying like, hey, this is what I've been doing. I've been babysitting this technology for so long, and if I no longer have to do this, how does that change things?
That's a great question, Scott. I've been through many technology transformations in my career, and that's always the initial concern. When you introduce something that completely changes, right, the operating model and your teams. And what I've found is if you bring them along and you actually show them what they can do with this new capability. One is it gives them tremendous visibility, and they start things that was hard for them to do in the past becomes very easy for them to do. And then they build on top of that. So I think it is a new skill that gets learned, but they also find then ways to add value on top in a way that they could not done it in the past. So, I think that you're 100% right. You have to think about that transformation. You have to think about that human factor. You have to bring them along. But I think you're giving them access to technology they've never had before.
Yeah, and freeing them up. I mean, I would imagine once the penny drops for them and they understand it, they kind of go, oh, I can do a whole bunch of other stuff that I didn't have time for before.
Yeah, no, absolutely. And then the other one is, just to touch on another aspect in terms of a change is Outpost was designed from a security perspective to be able to run anywhere. So it's designed to be very secure. We have a system called the AWS Nitro system. And what the AWS Nitro system gives us is, one, it allows us to fully manage that infrastructure, meaning those servers, the software updates, without impacting our customers and our workloads. So that is really the technology that allows me to, or Amazon allows Amazon to manage that infrastructure in somebody else's data center completely seamless to the applications running there. It's the same technology we use in our regions, we use it in Outpost. But it also gives you tremendous amount of security. And so, where sometimes you will see in private data centers, they have these cages because they have different workloads with different security requirements. Outpost really solves that problem in an innovative way that each Outpost rack is 100%, and each server in the Outpost rack is secure through, using our AWS Nitro system.
Is that as simple and transparent as it sounds? Is that because it's all using the same software stack?
We have a very innovative way we've done this. If you think about most systems that manages infrastructure, it runs on the same infrastructure. So the application that's used to manage runs on the same physical server as the workloads. And we call these applications, they run very low level. They monitor the server, they look at the CPU, they monitor the disks, the memory, and they're also responsible for updates at that very low level, at the infrastructure level. But it all runs on the same CPU, memory, and storage that the rest of the applications run in. Nitro is very different. Nitro runs completely on the side. It doesn't run on the same CPU, memory, and storage as the applications. It's a complete system on the side that allows us now to monitor the infrastructure without needing to use any of the CPU. So 100% of our compute storage network is available to the applications. We don't use any of that. And it also then allows us then when there is, for instance, a big security update that needs to be deployed, we can deploy it seamlessly without the customer even aware that we update. So by the time that a security breach has been published, we can inform our customers that we've already updated it. And there was no action needed on their side.
Right. As you look forward at the next stage, you said you've been through several technology transformations, and it always feels like the one we're in, because it's always the best one we've ever had. It always feels like, oh, we're here, we're there, but there's always one sort of waiting. When you look out into the future at edge and cloud computing and how computing itself is going to be changed by this, what do you see in terms of the future?
First of all, compute, and when I think compute, I'm thinking compute, storage, network, those three elements. I think we will find use cases to push it deeper and deeper into the edge. We spoke about we have Snowball in space, but I think in terms of pushing it deeper into the edge, that will continue. And we're very excited. We just announced the first availability of the AWS private wireless solution, private 5G solution, which is an example of a service now running in a Outpost on-prem to provide connectivity. And what it does is for IoT devices that runs on 5G in let's say in a factory or a warehouse with the robots moving around, it now allows those devices to connect through the wireless solution into the cloud and take advantage of all of the IoT, machine learning, AI capabilities we have in the cloud. I'm very excited that I think the capability of pushing cloud deeper and deeper is solving real world use cases for customers. And I think that journey will continue.
Yeah. I mean, you mentioned that the private 5G works very well with outposts. Would it also work with snow if you didn't have connectivity? Could you be somewhere in the middle of the desert running a smart factory?
Absolutely. So our intent with the 5G, if you think about private 5G, there's obviously the antenna that the devices connect to, but then that connects into the core system, and that core system will be able to run in a region, in a local zone, in an outpost, and in the snow. And based on your use case, or how you want to use your network and what needs to connect to what, you have that optionality of where you want to run it.
So if you bring that giant semi-truck-sized snow, that's a snowmobile, I think. You could sort of run your own show in Antarctica, it sounds like.
You can, one of the early trial customers were literally the customers who had events where they needed 5G technology for their own systems at the event. And now the ability to literally bring in a truck, put up the antenna, one or two antennas, and connect it locally on an Outpost server, and you have instant connectivity for the event. And that is actually a really, really good example of a use case that we see adoption in.
Oh, that's amazing. Jan, this has been a really fun conversation. Thank you so much for joining us today. This was really great.
Thank you, Scott. I appreciate the opportunity.
This custom episode is produced by Fastco Works in partnership with AWS. I'm Scott Alexander. Our producer is Avery Miles, and our editor is Nicholas Torres.